Hi and Assalamualaikum everyone. My name is Muhammad Firdaus bin Malpi. My numeric is 08DKM24F1273. And today I'm going to talk about instrumentation and measurement systems. To start with, instrumentation is the science and technology used to measure, monitor, and control physical variables in a system. These variables could be temperature, pressure, flow, level, voltage, and many more. Instrumentation use devices such as sensors, transducers, signal processors, and display units to convert real-world physical quantities into readable and usable data. And now, why do we need instrumentation? There are five main purposes. The first one, measurement of physical quantities. It allows us to measure variables accurately, ensuring the system works correctly. The second one, process monitoring. Instrumentations help operators observe system performance continuously and detect any abnormal condition early. The third one, process control. It allows system to maintain variables within desired limits using automatic control system, which is crucial for industrial processes. The fourth one, safety improvement by detecting unsafe conditions such as high temperature or pressure. Instrumentation prevents accidents and equipment damage. The last one, efficiency and productivity. Accurate measurement and control help optimize system performance and reduce energy waste, improving productivity. Now, let's look at how a measurement system actually works in terms of its main functions. A measurement system in instrumentation performs five main functions. The first one, sensing. The first step is detecting the physical quantity using a sensor. For example, a temperature sensor can detect heat inside a system. Second one, transduction. The sensor's output is usually converted into an electrical signal by a transducer, which make it easier to process. The third one, signal conditioning. The electrical signal may be weak or noisy, so it needs amplification, filtering, or modification to improve accuracy. Next, data transmission. The processed signal is sent to a display or control system, either via wires or wirelessly. And the last one, data presentation. Finally, the measurement is displayed, recorded, and stored, so it can be interpreted or used for controlling the process. These functions ensure that raw physical data becomes meaningful and actionable information in measurement system. Let me show you a simple diagram that illustrates this process along with a real industrial example. This is a basic measurement system diagram. The physical quantity like temperature is first detected by the sensor. The transducer converts it into an electrical signal. The signal is conditioned, transmitted, and finally displayed or used to control the system. To make it more practical, let's look at a temperature control system in a chemical plant. A temperature sensor measures heat inside a chemical reactor. The transducer converts this temperature into electrical signal. The signal is amplified and processed in the signal conditioning unit, and then it is sent to a control system such as a PLC or a computer. And the last one, the temperature reading is displayed on the control panel, and the system automatically adjusts heaters or cooling system. All right. And now let's move to the measurement system and their outputs. First, let's look at inputs. Inputs are the physical quantities we want to measure, such as force, pressure, temperature, voltage, or chemical concentration. The outputs are the signal or information produced by the system. They can be mechanical, like a pointer moving on gauge, electrical, such as voltage or current signal, digital, which is a binary signal used by computers or controllers. Essentially, outputs are how the measurement system communicates. The the detected input to the operator or control system. Next, let's compare these output types and see how they differ. Mechanical outputs are simple and direct, such as pointer movement or physical displacement. They are limited in accuracy, difficult to transmit over the long distance, and also hard to integrate with electronic system. Electrical outputs like voltage or current signals are more versatile. They are easier to transmit and connect to control system, but they can be affected by electrical noise. Digital outputs are the most accurate and convenient for modern automation. They are easy to store, transmit, and process using a computer or PLCs. Here's how a typical measurement system works. A sensor detects the physical quantity. A transducer converts it into an electrical signal. The signal is conditioned and then it is delivered as a mechanical, electrical, or digital output, depending on the system design. Finally, let's look at a practical industrial example. Gas pipeline pressure monitoring. In a gas pipeline, pressure must be monitored continuously to ensure safety and efficiency. A pressure sensor detects the gas pressure, which is then converted into an electrical signal by a transducer. The signal is conditioned and amplified and delivered through multiple outputs, such as mechanical, a local gauge pointer for on-site observation, electrical, analog signal sent to PLC or control, digital, data sent to a computer system for monitoring and logging. This system ensures safety operation, continuous monitoring, and efficient process control. In conclusion, understanding inputs, outputs, and their types is crucial for designing a reliable and efficient measurement and a control system. Thank you very much.
Hello, good day everyone. Today I will present instruments assignment for instrumentations and control. So my name is Timothy Jonathan Jalinos and my number metric is 08DKM24F1305. So I'm from class DKM4C. So this is I will be represent about uh, differentiate between analog data, digital data, and pneumatic signal in instrumentation system. The second one is I will explain the concept of measurements errors. So, first is analog data. So, analog data is a continuous signal that changes smoothly over time. It directly represent physical quantities such as temperature, pressure, flow, or voltage. In instrumentation system, many sensors produce analog signal. For example, a temperature sensor may output a voltage signal that continuously varies depending on the temperature. Because analog signals are continuous, they can represent very detailed information, but they are also more sensitive to noise and interference. So the next one is digital data. Uh, Digital data is represented using discrete values, usually in the form of binary numbers, which are 0 and 1. Unlike analog signal, digital signal do not vary continuously. Instead, they switch between two, such as on and off. So digital data signals are widely used in modern control systems such as PLCs, computers, and microcontrollers because they are more reliable for data processing, storage, and communications. So the next one is pneumatic signal. Pneumatic signal transmit information using compressed air pressure instead of electricity. In industrial instrumentation, a common standard signal range is 3 to 15 psi. These signals are often used to control valve actuators, and other mechanical device in industrial processes. Although many systems today use electronic signal, pneumatic signal are still used in environments where electrical system may be unsafe or unreliable, such as hazard areas. Okay, that's for the end of the questions. So I will be moving to the next questions. Sorry, I forget to present this table. This is the analog data table. They have analog, digital, and pneumatic. So this is a measurement areas. Measurement error is the difference between the measure value and the true or actual value of a quantity. This is the formula of the measurement error is error equals to measure values uh, minus true value. This can occur due to several reasons such as instrument limitations, environmental conditions, or human mistake. There are three common types of measurements error: systematic errors, random errors, and gross error. Next is the type of measurement errors. Systematic errors occur repeatedly in the same directions. It is usually caused by incorrect calibration or faulty instruments. For example, a thermometer that always read 2 degrees higher than the actual temperature. So next is a random error. A random error occurs unpredictably and causes small variation in measurement result. It can be caused by electrical noise vibration or environmental disturbance. So the next one is gross error. Is mainly caused by human mistake such as reading the wrong scale, recording incorrect data, or using the instrument improperly. So to minimizing errors, to minimize measurement errors, several step can be taken. First, instrument should be properly calibrated to reduce systematic errors. Second, multiple measurements should be taken and averaged to reduce random errors. Third is proper and training and careful observations can help prevent gross error caused by human mistake. By reducing these errors, we can improve the accuracy and reliability of measurement system. So the conclusion is instrument system use different types of signal, including analog, digital, and pneumatic signals to transmit informations. However, measurements are not always perfect and errors can occur due to various factors. Understanding the type of measurements, errors, and how to minimize them is important to ensure accurate and reliable measurement in engineering system. So that's all from me. Thank you.
Hello everyone, my name is Suryavil Gobinath and my metric number is 08DKM24F1104. Today I will present the difference between open loop and closed loop systems, control systems, from question 16. A control system is used to regulate and manage the behavior of industrial processes so that the output reaches the desired value. Control systems are widely used in many industries and everyday devices. Open loop control system. An open loop control system operates without feedback. This means the output is not compared with the desired input and the system does not automatically correct errors. Because of this, open loop systems are simpler and easier to design. The examples for open loop are microwave oven timer, traffic light timer, washing machine timer. These systems operate based on preset instructions without checking the actual result. A closed-loop control system uses feedback. This means the system compares the output with the desired input and automatically adjusts the system if there is an error. Because of feedback, closed-loop systems are more accurate and reliable. The examples of closed loop system include air conditioner temperature control, car cruise control, automatic water level system. These systems continuously monitor the output and adjust it to maintain the desired value. This is the diagram for open loop and closed loop system. As you can see, there is no feedback for open loop while there is feedback for closed loop. And these are the structures. In comparison, open loop systems are simple and inexpensive, while closed loop systems provide better accuracy, stability, and reliability because they use feedback control. In conclusion, both systems are useful depending on the application. However, closed loop systems are widely used in modern industries because they provide better control, higher accuracy, and improved automation. And now on to question 4, which is components of an instrumentation system. An instrumentation system is used to measure and monitor physical quantities in industrial processes. These quantities include temperature, pressure flow, and liquid level. Instrumentation systems are important because they help industries observe process conditions and ensure safe and efficient operation. A basic instrumentation system consists of three main components: sensor, signal processor, and data presentation. Each component plays a different role in collecting and presenting measurement data. The first component is the sensor. A sensor is a device that detects physical quantities and converts them into signals that can be processed by the system. For example, a thermocouple is commonly used to measure temperature in furnaces. So basically, the sensor is responsible for collecting the measurement from the environment. The second end the second end component is the signal processor. The signal from the sensor is usually weak or not suitable for direct use, so it needs to be processed. Signal processors perform functions such as amplifying, filtering, and converting signals. Examples include amplifiers, filters, and converters. This step ensures the signal becomes clear and usable for system. The final component is data presentation. This part displays the measurement results so that users can read and interpret the data easily. Examples include digital displays, computer monitors, or control panels. This allows operation to monitor system performance and make decisions. For example, in a power plant boiler system, the sensor measures the boiler temperature. Then the signal processor amplifies the signal. Next, the display system shows the temperature in the control room. This helps operators monitor and control the system safely.